Well, hi there. Today we are going to go over probably one of the most important concepts that you've got to do. Today's work is what we call it's a brain work. Brain work. We are going to see this is your brain, and what we are going to do is we are going to take your perfectly normal brain and we are going to scramble it. Okay. We're not going to do anything magically hard to it, but we are going to say, do this stuff differently than you've done it before. So here's what I mean by that. In looking at algebra, a lot of people start off with this thing where they say, okay, I've got a problem. X plus 4 equals 7. And they say, so what's X? And everybody knows that X is 3 because 3 plus 4 is 7. And they think they're doing algebra. Yay, good for you. The problem is that isn't exactly how people in algebra do algebra. What it is it's taking something you already know and it's just saying, let's add an X to it and making the little step easier. What I'm going to do is actually ask you to think of it differently. I don't want you to see the X, the 4, and the 7. What I want you to see is basically a balance scale. If you think about those scales, I'm sure you've seen them, where they kind of have some sort of pivot point and they have a tray on one side and a tray on the other side, and then they're standing there. And you put junk on one side, what happens? Well, it gets deeper, and you get more on the other side, and it even goes further down. What you have here is think of the equal sign as that pivot point on the balance. Is that whatever's on this side has to be the same weight as what's on that side. They just have to be equal. And so when you're dealing with algebra, most of the time what you're doing is you're trying to find what something is equal to. For example, in this problem, I want to know what X is equal to. So really what I'm ultimately looking for is I'm looking for a balance scale that has X on one side and it's got a box of junk on the other side with a pretty bow. And so I want to know X is equal to that thing. And so if you think of it as a balance scale, up here back in the original equation, X plus 4 equals 7, I got some junk on one side and I got some junk on the other side. I want to know what does the X itself equal, not what does X plus 4 equal. So this is how we deal with it. We ask ourselves a very simple question, and it has nothing to do, well, very little to do with math. Is if you had a balance scale and you got two things on it and you only want one thing on it, what do you do? Well, the answer is you take it off that thing. So I have an X and I have a positive 4. I have two things on this. So how can I get rid of the positive 4? The answer is, well, how about I subtract 4? If I take those 4 off, what does that give me? It gives me 0, because positive 4, negative 4 is equal to 0. So that gives me just X. So essentially, I'm taking this 4 and just removing it. Okay, but what does that do to the balance scale? Well, the answer is it makes it go all tilty. So instead of this, it goes like this, and that's bad. Bad to have a tilty balance scale. So, but if I do something to one side and I do the same thing to the other side, then it doesn't change. So if I subtract 4 from the other side, I haven't wrecked the balance. Notice I've got an X and a 4, take 4 off, but if I take 4 off both sides, it still stays balanced. So on this side, I took 4 off so that I could get X by itself. On this side, I take 4 off and I get X is equal to 7 minus 4, or 3. And I now know X is equal to a magical 3 down here. It is now balanced. Now, I started off by saying X plus 4 equals 7. What's X? Well, the answer is 3. Notice that my process, which is much more scrambled in your brain, gets you the same answer. We're going to learn how to do this kind of problem and more complicated ones using this process rather than just figuring it out in your head, because you won't be able to figure out some of this stuff in your head. I shall continue. Okay, I'm going to do a couple more examples just to make sure it's super duper duper clear. All right. Let's try new letter, Q. Why? Because Q is spiffy. And we're going to say Q plus 10 equals negative 25. Okay, so this is very similar to the last one. The only thing different is I threw a negative number in there just to make it comfortable. So if I think this is a balance scale, I have a Q and a 10. On this side, I have a negative 25 on this side. They are balanced. Life is good. I just want Q all by itself. So to do that, what I normally do is I just put it underneath what I'm going to do to it. I'm going to take away 10 because a positive 10 and a negative 10 is equal to 0. That's the whole point. So they just go away. So all I end up with is a Q. But if I take away 10 from this side, I have to take away 10 from this side. And a negative 25 and a negative 10 is a negative 35. The end. There, you solved it. That's that. All right, let's try one with a negative sign in a little different spot. That's right. T minus 4 equals 9. Okay. In your head, you're saying, well, what minus 4 is 9? Well, 13. 13 minus 4. So we know the answer. That's not the point. We're going to do the problem where we say, okay, I have a T on this side, and I have a negative 4 on this side, and I have a 9 on the other side. To get rid of the negative 4, what do I got to do? I've got to add 4. So the key thing is to get rid of this, what do I have to do? That is the question of your life. To get rid of this, what do I have to do? Think of it as an annoying younger brother. To get rid of this, what do I have to do? And then you just do it, whatever it is. So there's no like one procedure. Sometimes you just remove him. So I'm going to remove this negative 4 and this positive 4 by just, or negative 4 by adding 4. But if I'm going to add 4 to that side, I'm going to add 4 to this side. Because I know that is equal to 0, I end up with T is 13, which you knew already because you know how to do simple arithmetic. But that's the process you do this. So in your book on page 89, you just have a bunch of these to do. They're not very complicated. That's kind of as hard as it gets. But I'm going to add one more thing. At the end of this, you do have, hey, what about this? And you've got a problem like, I'm just going to make one up that's similar. 45 plus, we'll use P this time because P is a happy number. Actually, it's a letter, but don't tell anybody. 94 equals 71 minus 8. Okay. I want to know what P is equal to. Well, same basic concept. However, I can do some things first to make it simple. So, for example, I know that 71 minus 8 is equal to, that's right, 63. You did that in your head, right? And I know that 94 plus 45 is right, 139. You did that in your head. Or you used a computer. So I can make this a little simpler without really changing it. Just think of these as like I've got a penny and I've got a bunch of numbers. If I just add all those numbers together, I haven't really changed anything. I've just combined them to make it simpler. So now I have this one, and I go to my balance scale where I've got a P, a 139, and on this side I've got a 63. They are balanced. So I'm going to subtract 139 from this side because that is equal to 0. And so I have P, I've got to subtract 139 from this side. Okay, and then your head goes, what do I do? Well, you have to remember a little bit of math. When you have a positive minus a negative, or a negative minus a positive, you take the big number, 139, minus the small number, 63, and do the math. 9 minus 3 is 6, 13 minus 6 is 70, and you take the sign of the bigger number. That's a negative, that's a positive, so it's going to be negative 76, and that's your answer. That's as hard as you'll get on section 3.5 on page 89 and 90. Now, new stuff. What if you have something like 6 times y equals 18? Okay, first thing to remember is, again, that's kind of the simple one, is that when you have a number next to a letter, that means multiply. It means 6 times y. You've got to get it out of your head that you're ever going to use X for times or dots for times. It's typically, if you have two numbers next to each other, like 5 times 3, you would say 5, and then you put a parentheses 3. If you have a letter next to a number like this one, you would say 6 times y. That's what that means. Well, Okay, so here's what you've got. Think of these as things as opposed to letters. So I've got 6 times y is 18. Well, 6 times what is 18? The answer is 3. So you already know the answer. I picked an easy one, so you would know it. Most of these are easy in your homework because you'll know them. But the idea is to think of it as a balance scale. So if, I'm going to say Y stands for yaks because we like yaks. Yaks are nice, big, giant cows from the Himalayas. So I got 6 yaks equals 18. That's nice. So what's a yak equal? Well, I can't just subtract 6 because that would be 6 numbers. I've got 6 yaks, 18 numbers. Those are equal to each other. I can't just get rid of the 6 by taking 6 away. What I have to do is I have to divide by 6. Why do I do that? Because anything over itself, 6 over 6 is equal to 1. So just to remind yourself, so for example, 3 over 3, what's that equal to? 1. 5 over 5 is equal to 1. Okay, anything over itself is equal to 1. So what my goal is to get the y all by itself. So to do that in this particular thing is I'm not subtracting 6. I'm looking at how can I get rid of the 6? Answer is divide by it. But if I divide one side, I've got to divide everything on the other side. So 18 divided by 6 is 3. Done. So that's the kind of thing you'll have. Here's one more example. I'm going to try one of, and I didn't do this in class, so I'm going to do it now. Let's say I've got n over 20 equals, pick a number 3, because 3 is my favorite number, I guess. It's my favorite number today. So n over 20 is 3, and I look at this and I go, I got this on one side of the scale. Remember, I got my little scale. Scale. Sound effects help. N over 20, and then 3. They are now balanced. Okay, they don't. And I want to just have, again, my goal is to have my little balance scale with just n and then a nice little box of something. I don't know what it is yet. What do I got to do to this to not have that stupid 20 in the denominator? Well, here's the deal. So what is 20 over 20? The answer is, you guessed it, 1. Okay, well, what if I multiply this side by 20? Then this becomes 20, I'm going to write it a little different, 20 over 20 times n equals 3. You see that? I can kind of move that 20 out front, and it's the same thing. So if I multiply the left times 20, I got to multiply the right times 20. And so what's 20 over 20? 1. So I have n equals 3 times 20, which is 60. 60. And that's the kind of work you have. I do one more for you that puts these two together. You actually don't have this in homework, but I want you to see why you got to do this because otherwise you will be in trouble. You can't do these things in your head. So let's say, for example, I've got 3x minus 5 plus 7 minus or equals negative 2x plus 10. Okay, so there we go. So I've got this problem, 3x minus 5 plus 7 minus 2x plus 10. What is my goal? My goal is you have to ask yourself, what is the goal? To have x on one side and all the other stuff in a pretty little box on the other side. Okay, I'm looking at it and I'm asking myself, do you have x on one side? And I would say, well, I have this thingy on one side and this thingy on the other side. No, x is not by itself. What do I do, self? Well, a couple things I can do. First, I noticed there's x's over on this side. I don't want them on this side. And when you don't want something, what do? You throw it away, just like that little brother you wanted to get rid of. So how do I get rid of that 2x? I'm going to add 2x, because what's negative 2x plus 2x? It's 0. Okay, but if I do it to that side, I'm going to have to do it to this side. Okay, so that gets rid of these guys. Now, I'm going to do this first. I have negative 5 plus 7 is 2. 7 minus 5, 2, yeah. So I'm going to simplify that. Okay, now you'll notice it's starting to get messy. Well, this is what I do at this point. So I just rewrite it. 2x plus 3x plus 2 equals 10. So this is where you have to, when you're doing these problems, kind of do it in several steps so you don't lose something or you get mixed up with what's happening up there. Well, 2x plus 3x is just 5x. So I'm going to rewrite that again. 5x plus 2 equals 10. You will now notice this is very similar to what we were doing before. It's a very simple one. I want x's on that side. I still have a 2 on this side. How do I get rid of the 2? The answer is that little brother goes out the door. Bye, little brother. And he goes to 0. But he has to go into your sister's room. So if you do it on this side, then you got to do it on the other side. And so now I have 5x equals, what's 10 minus 2? That is 8. So I'm almost to x by itself. One last step. How do I get rid of this 5? Well, I can't subtract 5. That doesn't make any sense. But I can divide it by 5 because 5 over 5 is 1. And so if I do that on that side, I do it on the other side, and I end up with x is 8/5. So as you can tell, when I had 3x minus 5 plus 7 equals negative 2x plus 10, there's no way you would have guessed that x is equal to 8/5 like you did in some of the homework. You're going to have to use this process to get to what is x. And it's really not that complicated. It ultimately goes back to this here. All right, have fun with your homework, and see you later.